Hello, ladies, gents, and everyone. It is Thursday, February 10th, and we're here to talk about this week's space and astronomy news. You know all those samples that Perseverance is collecting? Well, we just got a little bit closer to seeing those actually make it back to us here on Earth. The Mars Ascent Vehicle, or MAV, is a rocket that will launch from the surface of Mars to take those samples up into orbit, where it will then rendezvous with ESA's Earth Return Orbiter, which will actually bring the samples back to Earth. And NASA announced on Monday that they have awarded a contract to build MAV. The contract went to Lockheed Martin Space. MAV is absolutely going to be an engineering challenge, and if all goes according to plan, it will be the first rocket that will ever launch from the surface of another planet. Now, MAV's journey to Mars is planned for no earlier than 2026, which would put its launch from the surface of Mars in around 2029. Measuring positions on the sky is hard enough, but doing it in 3 dimensions plus velocities is all kinds of challenging. But ESA's Gaia mission has been revolutionizing our ability to do this since it launched in 2013. Gaia orbits out at the Earth-Sun L2 point. It just got a new neighbor out there with the Webb, and it has so far measured the positions, parallaxes, and proper motions of almost 2 billion sources. And ESA is gearing up for the next release of data from the Gaia mission. This is Data Release 3, or DR3, which is the third of 4 planned data releases from the primary mission of Gaia. DR3 is going to have even more precise measurements, plus it's going to have solar system sources, a million quasar hosts, hundreds of thousands of binaries and triple stars, plus this whole photometric time series for 1 million sources, and just It's a lot. It's a lot of data, and it's really exciting. ESA announced this week that DR3 is going to drop on June 13th, and let me tell you, astronomers the world over are salivating for this data. We tend to think of asteroids as boulders just tumbling chaotically through space, which isn't entirely inaccurate, but it's actually quite common for asteroids to form little systems. You may recall that the target of NASA's DART mission is the moonlet of one such binary asteroid. And we've even known of a handful of triple asteroids over the past several years. But now, for the first time ever, we actually know of a quadruple asteroid system. This is the asteroid 130 Electra, and it was known to have 2 moons. And now astronomers have used a new data reduction technique on archival data from SPHERE and found a 3rd moon. This moon is about 1.6 kilometers in size, and it orbits the primary asteroid at a distance of about 350 kilometers on a rather inclined and eccentric orbit. This is great news for that new data reduction technique, and it's just a really cool find. Some bad luck for SpaceX this week, as a geomagnetic storm caused the loss of at least 40 Starlink satellites. A batch of 49 Starlink satellites was launched last Thursday. Now, after Starlink satellites are launched, they're placed in a temporary low orbit. And while they were in this low orbit, the geomagnetic storm actually increased the density of the upper atmosphere, which caused an increased amount of drag, a quite significant increased amount of drag, which started deteriorating the satellites' orbits and got them placed into safe mode. Now, while space weather can be very difficult to predict, this storm was actually known and forecasted at the time of launch, so it's a little unclear what exactly went into the decision-making process at SpaceX to go ahead with the launch. Now, even in safe mode, at least 40 of the satellites could not recover their orbits, and they have either already entered the atmosphere and burned up or are about to do so. Now, there are almost 2,000 Starlink satellites in orbit, so this is really just a drop in the bucket for the constellation as a whole, but it definitely raises even more questions about the already controversial mega constellation. On the bright side, some pretty cool videos have surfaced online of what might be the satellites burning up on re-entry. The Parker Solar Probe is a NASA mission studying the sun. You may recall its epic feat last year of literally entering the sun's atmosphere. But on its journey around the sun, the probe passes some other targets, such as Venus. The probe flew by Venus back in July of 2020 and captured these images. Now, Venus is covered with a very thick and opaque atmosphere, so the goal of these images was actually just to look at the surface of the cloud tops. But there were some tantalizing hints that they were actually seeing glimpses of the surface. So when the probe flew by Venus again in February of 2021, scientists captured more images. And now this time they've been able to confirm that they are in fact seeing the surface of Venus in visible and near infrared light. This light is light that's actually being emitted by Venus itself because the planet's surface is just so damn hot. They were able to see the entire night side of Venus on the February 2021 flyby, and these results were published this week in the Geophysical Research Letters, and this is just a really bit of unexpected and exciting science from the Parker Solar Probe. About 1 in every 1,000 stars is massive enough to create a black hole when it dies. So these types of stellar mass black holes should be relatively common throughout the galaxy. But black holes are, by their nature, almost invisible. Detecting stellar mass black holes then relies on being able to see their interactions with other objects, such as gravitational waves from mergers, or light emitted from accretion disks, or the orbit of a binary companion. For example, the first time a stellar mass black hole was ever detected was an X-ray binary, Cygnus X1, back in the late 20th century. But now astronomers have used a technique called microlensing to detect the first ever lone stellar mass black hole. The microlensing technique takes advantage of the fact that mass bends space-time into a lens and can cause the brightness of more distant objects behind the lens to change. The team used many ground-based observatories to identify and follow up this candidate, including 6 years of Hubble observation, making it a very convincing candidate, although I should mention that this research is currently only publicly available as a preprint. They were even able to measure the velocity of this black hole, which they found was slightly more than the average speed of neighboring stars, which could be a sign of the nice kick from the supernova that formed it. A really cool detection, and congrats to this team for a really exciting discovery. That's it for this week. Thanks so much for watching, and I will see you again next week. Have a good one, and happy Valentine's Day. Bye!